Hello world! My name is David Silver. I am the team lead for the Udacity self-driving car Nanodegree. If you're watching this, probably you know that, but if you don't know that, hello! We have all sorts of folks tuning in today. We hope we have students who are starting term 3 of the Nanodegree program, which launches today. We have Udacity students who aren't starting term 3 yet, but plan to be in the future. And we've also invited folks who aren't even Udacity students yet, because this is really one of the first times we've talked a lot in detail, or we're going to talk a lot in detail about term 3 and what we cover in this part of the Nanodegree program. So hello to everybody. I'll take a little bit here and walk you through the classroom for term 3, show you what we have published for students to dive into already and what things are coming in the future. And then you guys can shoot any questions you want over the YouTube channel, and we're happy to provide all the information we can. So let me do a screen share here, and I'll show you what the classroom looks like. So this is the classroom for the for term 3. You can see there are 3 terms over here, term 1 and 2, and then term 3. Term 3 is path planning, concentrations, and system integration. So term 1 starts with a welcome video, and then we dive into the first substantive part of term 1, which is the path planning module. And the first lesson in the path planning module is search. And this is actually one of Sebastian's lessons from his free AI for robotics course. So if you've already taken that course and you feel like you really remember the search lesson really well, then feel free to skip ahead. But this is some pretty foundational material for path planning, and Sebastian does a really nice job teaching it. So we're including it here to kind of get everyone up to the same level when we dive in with the new content. The next lesson is prediction, and this is taught with our partners at Mercedes-Benz Research and Development North America. We had the really great pleasure of working with their vehicle intelligence team, which are some of the best path planners in the industry, for building the path planning lesson. And they break path planning up into 3 distinct parts. So the first part is prediction, and that's this lesson here. And prediction is studying or estimating what we think other vehicles on the road are going to do. So if you look at this graphic here, imagine we're the blue vehicle. We're trying to figure out, what is this green vehicle going to do? Is it going to turn right at this intersection? Is it going to keep going straight? And there are a variety of ways to think about that. We can model it. We can have models and see if we think the blue vehicle or the green vehicle is making a right turn or going straight. We can have data-driven approaches and use machine learning to try and figure out, is the green vehicle acting like what we've seen cars in the past act like when they turn right or when they go straight? Or more accurately, given what we've seen cars in the past do, what does it seem like the green car is going to do based on what the green car has done so far? And we can have hybrid approaches where we combine both models and machine learning to try and figure out what the green car is going to do. So that's the prediction lesson. The next lesson in path planning is behavior planning, and this is trying to figure out what we should do. And this is a really hot area of research, and kind of the foundation of all of the research into behavior planning is finite state machines. And so what you see here, this kind of what a mathematician would call a graph of blue nodes and white edges, or blue circles and white arrows, is a finite state machine. Essentially, each state here are different states that our vehicle could be in, and what we want to do is figure out how to transition from one state to the next to get where we're going. We're going to think particularly about highway driving. And easier to start with than urban driving. And what you can see is in highway driving, we have a variety of different states. Maybe we can accelerate, decelerate, keep our speed, shift lanes to the left, prepare to shift lanes to the left, and so forth. And you'll learn about how to build and implement a finite state machine for path planning as part of the path planning module and the behavior planning lesson. The next lesson in path planning is actually not ready quite yet, but we plan to release it next week. We're just waiting on the last animations to come through, so everything looks nice and it's ready to go. And this lesson is trajectory generation. So if you think about path planning, we've started out by trying to predict what other vehicles around us are going to do. Then we have used a finite state machine to figure out what maneuver we want to undertake. And the last thing we want to do is figure out what trajectory do we actually want to follow. So it's one thing to say we want to shift lanes to the left. It's another thing to actually build the trajectory that shifts lanes to the left. So if you imagine we're this blue vehicle here, we've decided we want to shift lanes to the left. And there are all these different trajectories that we can follow. And some of them might be unsafe. Some of them might be uncomfortable. We want to select the lowest cost trajectory, the one that is optimal for our purposes, so that we can execute that left-hand lane shift safely and comfortably. So that's trajectory generation. And then the project for path planning is actually ready now, but it's a little hard to complete if you haven't done the trajectory generation lesson, which isn't quite ready. But if you feel ambitious and you're ready to go, you can actually dive into the path planning project now. We use the Udacity simulator that you all are probably familiar with, but a little bit of a new version of it that actually has traffic on the highway. And you get to navigate traffic on the highway with your vehicle and figure out how to maneuver around traffic and basically do path planning in order to travel around a multi-lane highway loop. So that's a really fun project. I'm excited to see what you guys do with it. You guys always have really neat implementations and different ways people approach the project, and I think this is the type of project that allows you to do a lot of really neat things and people to submit solutions that operate differently. And so I think we're really excited to just kind of see where it goes. And that's path planning. After path planning, we have a couple more lessons, or a couple of elective modules. So we have one elective module on advanced deep learning and one on functional safety. And in a few weeks, we'll ask you to choose which of those elective modules you'd like to pursue. You get to choose one, and if later you decide you want to do the other, we're going to make that possible. But you get one as part of the Nanodegree, and then we're working on exactly the economics for allowing you to do the other elective. But we want to make it possible for you to do as many of them as you would like to do. The advanced deep learning module we built in partnership with our friends at NVIDIA, and particularly their Deep Learning Institute, which is their educational arm. And they really pushed us to take deep learning take you to the cutting edge of deep learning. We initially talked with them about running through some bounding box models like YOLO and single shot detectors. And we do talk about that a little bit in this module, but they really wanted to go right to cutting edge, which is semantic segmentation. Semantic segmentation is the act of coloring image based on what class it belongs to. And so if you see this image right here, this is a segmented image. Essentially, we passed in a real image, and then each color in the image represents something different. So we have kind of light green for signs, and dark green for background, and blue for sky, and purple for cars, and some sort of roads, and pink for the sidewalk. Segmentation. Now it turns out that this kind of semantic segmentation, where we have like 10 different classes, is really computationally difficult and expensive. And so we're going to start with a little bit more basic segmentation, where we're simply working with two classes, road or not road. So if something's not part of the road, we leave it as is, and if something's part of the road, we color it. But you can extend the same principles to multiple classes, just like you can with a regular neural network. Do one classification or many classifications. And this is really like the cutting edge right now of autonomous vehicle deep learning, is figuring out how to segment roads or scenes, because that helps us understand the scenes better and gives us more information than bounding boxes by themselves do. The final lesson before we get to the semantic segmentation project, the final lesson in advanced deep learning is what we what are called inference optimizations. This is making your network run faster. And the reason we focus on that here is precisely because semantic segmentation is so computationally expensive that even in production, once you train the network and you have a network ready to deploy, it can't run that fast because it requires so much computational power. And so we need to do perform a number of optimizations to get the network up to real-time speeds. And so we cover things like fusion and quantization and reduced precision. So, for example, using ints instead of floats in the network in order to make the network run faster. And a lot of that is handled by the compiler, but we teach you kind of how to get the compiler to accelerate the network so it runs faster. So that's the advanced deep learning elective. The other elective you can choose is functional safety. So functional safety is a systems topic that all automotive engineers need to know. We built it with our partners at Electrobit. Functional safety primarily is built around the ISO 26262 standard. That's a really important international standard for automotive engineering. That's the standard that covers functional safety, reliability, redundancy for electrical and electronic components. Interesting module for us. It's as of right now, at least, it's the only module in the Nanodegree where we actually don't write code. It's really a systems analysis module. So you start out off kind of looking at the system at a very high level. You build a plan for creating a functionally safe system, and you undergo a hazard analysis and risk assessment where you try and think of all the different things that could go wrong with the vehicle, and you categorize them in a few different ways and try and figure out what level of safety and redundancy you need for each type of problem. And this isn't kind of done ad hoc on the fly. There's a very systematized way that automotive engineers need to do this. The next few lessons are about building what are functional safety and then technical safety concepts. And this is at kind of a high level, and then at a lower level, how do you solve each of the problems that you came up with in the hazard analysis and risk assessment, and how do all of these pieces fit together in the system diagram so that you're not spinning your wheels, spending all your time adding redundancy to parts of the system that don't need it, and focusing on making safe and reliable the parts of the system that are likely to fail and are likely to cause really big problems if they do fail. Lesson of the Nanodegree, or of the functional safety module covers some of the implementation details, things like MISRA C++, which is a set of rules for writing functionally safe C++ code. That's not part of the project. We're thinking that maybe later we might release a lab that covers some MISRA C++ topics. Over, in general, what is MISRA C++, what are some of the important rules, and as well as what are some of the other issues with software and hardware that might cause failures that you need to guard against and how to guard against them. But the primary focus of this module really is system analysis, as functional safety is at its core. It's analyzing the system and trying to figure out how could it fail and how can we make it safe. And it's also the module where we kind of slide in a lot of information about the automotive industry and how the automotive industry works, how different roles function on automotive teams, and how different companies, OEMs and tier 1 suppliers and tier 2 suppliers, how those companies relate to each other and work together to build autonomous vehicles. Because often creating functionally safe systems involves working across the multiple companies that provide components to automotive systems. So those are the two electives that we're launching with. We anticipate adding more electives over time, and as I mentioned, if there are other electives that we add that you're interested in, we are committed to enabling you to take those, providing a way for you to take those. We're still working out the exact details, but as we roll out additional electives over time, you'll have the opportunity to dig in and take those if they're interesting to you. The final lesson of the course or of the Nanodegree program is system integration, and this is kind of what we've been building up to the entire time. Actually, sorry, before I finish, I should just tell you these electives will be launching towards the end of July. So the due date for path planning is August 6th. We anticipate launching these electives a couple of weeks before the path planning project is due. So if you finish the path planning project early, you should be able to dive into the electives. And we anticipate launching the system integration module in mid-August. The system integration module is where you actually get to put your code on the real Udacity self-driving car sitting out in our parking lot right now. So the system integration module, I was just reviewing scripts for it today, actually, covers several different lessons. It covers the vehicle subsystems on our car. Our car is called Carla. We're very proud of that name. Sensors, perception, planning, and control, which are the key subsystems on Carla. The module covers ROS and AutoWare. ROS stands for Robot Operating System. And it's a really important robotics and now automotive middleware. It's a little bit of a misnomer because it's called Robot Operating System, but it's not actually an operating system. It's a published subscribed middleware that manages communication and processes running on all the different components of an autonomous vehicle. And then AutoWare is another open source automotive library that provides somewhat higher level functions than ROS, things like localization. So we use both ROS and AutoWare on the vehicle, and as part of the final project where you put your code on the vehicle, you'll write nodes for both ROS and AutoWare where you integrate things like controllers and traffic sign classifiers and path planners into the ROS and AutoWare infrastructure of our car, and you'll do that on teams. As we get closer to the launch of this module in August, we'll be putting students from this cohort on teams so that you can work together in teams to get the code running both in our simulated environment. We've created a nice, we've adapted our existing Udacity simulator to work with ROS and AutoWare. Ultimately, when the code's ready, put it on the vehicle. The final lesson in the whole Nanodegree program and in the system integration module is system integration. And this is how you plug your nodes into ROS and AutoWare, how you get the car running, and how you deal with all of, maybe not all of, but at least some of the problems that come up with developing code for use on an actual vehicle. Things like hardware failures, latency, messages taking too long to get from one place to another, messages disappearing between one place and another, processes crashing, all sorts of things that when you build simulators, everything kind of works just fine. But when you do things in the real world, things start to go awry, and how you start to deal with that. And that's the Nanodegree program. The final capstone project is Carla, is getting your code on the Udacity self-driving car. We are really, really excited about this. We're doing a lot of work on this right now to prepare it for you and get everything ready. We want this to be as exciting for you as it was for us to build, and as exciting as we hope that the lead up has been. This is really a really awesome opportunity. I wish I had this opportunity when I was teaching myself to become an autonomous vehicle engineer. I didn't have any way of getting my code on a real actual car. And so we're really excited to present this to you and to work with you to make it an awesome project and hopefully even build out an open source autonomous vehicle software stack with your help over time. So we think it's going to be a lot of fun, and we are really excited to get going on it with you. So that is the Nanodegree program. I know those of you who are about to start this have put in a lot of work over 6 months, and we are really excited to work with you over the next 3 months to finish the Nanodegree program, to help you find jobs in the field. We are continuing to scale out our hiring partnerships and doing a lot of work with partners, trying to prepare them to move students into jobs at their companies, particularly as students start to earn the Nanodegree credential and really start to look hard at maybe moving into the field. So that's a big focus of ours as students finish the program, and we're really excited to help you through to the end, and we're grateful to you for traveling the journey with us. I think that's it as far as the curriculum. I'll touch on a few things that you're probably familiar with from previous terms before we dive into questions. So we have deadlines this term as we have in previous terms. It's still a little bit of an open question whether we will have a pass-fail deadline for the Carlo project. There'll be a date at which the Nanodegree ends, but whether or not pass something like get the car to drive around a test track, we're still deciding on. But all the other projects have deadlines or due dates, and there's a deadline at the end of the term by which you'll have to pass all the projects, just like in term 1 and term 2. If you look in the classroom, you'll see the due date is October 15th. So certainly you can pass the projects before then, and we encourage you to, so it's not right up to the wire, but same deadline policy as before. Mostly the same resources this term as we have had in previous terms, with one big difference, which I'll get to in a minute. So we have forums, we have Slack. We also have something called the Live Help, which is new for term 3. This is a button that you'll have in the classroom where you can ask a mentor, any mentor around the world, for help on a problem you're working on right now. So this is a little different than the mentorship setup we've had in term 1 and term 2, and this is kind of an experiment for Udacity. In term 1 and term 2, you had a specific mentor who might have been in your time zone or might have been all the way around the world, and you would send them a message, and ideally you would get a response within 12 or maybe 24 hours. And we know that can be really helpful for kind of keeping you on task and helping you with due dates and checking in, but it can sometimes be problematic if you're in the middle of a problem and you can't get a solution and you want an answer right now. And so we're trying out Live Help as a mechanism. Instead of having an assigned mentor, you'll have access to a mentor pool from all over the world, and when you ask a question in the classroom, what we see in some of the smaller Nanodegrees we've rolled this out in so far is you get an answer within a couple of minutes. So, this is an experiment for us. We hope it goes well. We hope it proves really valuable. If it doesn't, we'll revert to our normal mentorship model. But we're excited to try this and see if it's valuable for you. Community is still there. I've been a little bit absent from the Slack community for the last several weeks as I've been kind of swamped with getting term 3 ready to go. But I anticipate being back in there in the next few days to respond to questions and to get feedback on term 3. We're also working on improving some of the things in term 2 that we've heard feedback on. So we really appreciate your presence and feedback in Slack, and just by emailing me at david.silver@udacity.com and letting us know how things are going. Filling out the surveys at the end of each lesson. That all is really helpful for us in knowing what we need to improve. I mentioned briefly our hiring partners. We, I believe, just launched a kind of a new batch of hiring partners. It's on our website, so if we go to udacity.com, and it's a few clicks away. Actually, we probably need to make it a little more prominent. Actually, I'll go to udacity.com/drive. Oh, sorry, I should screen share here. Let me get the screen share working. So if we go to our course homepage, which is actually here, the Self-Driving Car Engineer Nanodegree, and we scroll down, we can see a bunch of our hiring partners here. We launched a few new big hiring partners like Delphi, FCA over the last few months. And we are working actively to get jobs from these hiring partners up on the Udacity Hiring Partners Jobs Board. So Udacity Hiring Partners Jobs Board, I should probably have this bookmark. But if you haven't been to the Jobs with Udacity Hiring Partners page, this is a great place to come. You fill out which Nanodegree you're in. And you can fill out other Nanodegrees if you're interested in jobs, with artificial intelligence, say, and you can find jobs at different levels and you can apply to different positions, and we then try and help match you up with companies that are looking to hire people into your positions. So if you're into the positions you're interested in. So if you haven't been to the Udacity Hiring Partners Jobs Board and you're looking to get a job in the field, or even if you're just curious, we really encourage you to go check that out. It's how we're trying to structure the process of connecting students with jobs, because this is becoming a really, really big focus of what we're doing at Udacity, and it's a little bit new for us. We've always been focused on careers, but this notion of connecting students directly to employers is something we're really starting to focus on really hard now, and it's a little new, and so kind of helping us scale that out so we can help you find the right job would be a help to us, and also obviously a help to you, or we hope a help to you. The last thing you can do as far as hiring partners is fill out your Udacity portfolio or profile. So if you go to udacity.com and sign in, you'll find a link to build out your hiring profile, add your LinkedIn profile, your resume, your GitHub repositories, fill out different projects that you've completed as part of the Nanodegree program that you'd like to show off to employers. And having a really strong Udacity profile really helps us in connecting you with our hiring partners, because that's where we go to find the information to provide to our hiring partners. So that's ultimately what our hiring partners see when we refer you to them. So please fill out your Udacity profile if you're at all interested in with our hiring partners. So that is term 3 of the Udacity Self-Driving Car Nanodegree program. We are really excited to be here for a long time. This felt so far away as we were going through the process of building out our deep learning modules in term 1 and our sensor fusion module in term 2, and it's really exciting for us to be here and kind of be able to see the finish line and see students who are about to graduate of what we've done and also of what you've done. It's kind of amazing what all the students in the program have done, and that you've made it this far. So we're really grateful to you and really excited to see you through to the end. So I'll take questions. Let's see. And I know I was a little late in getting here. I apologize. So I will try and scroll up to the top and start at the beginning and answer any questions. So Tucker Dunn says, I would be very interested to know the enrollment statistics for the SDC terms. So term 2 date, I apologize, I should know that off the top of my head. I do not. I know the statistics I've been rattling off for a while about term 1, and those are basically stayed the same as we have and we are, one of our big focuses is actually trying to improve them, but they're actually, they're pretty good. So the statistics for term 1 are that about 50 to 60, about 55% of students complete term 1. And it's kind of interesting to look at where people drop off. About 20% of students never complete a single project. They don't complete the first week project at all. They don't ask for refunds. Usually we only see just a handful of people actually ask for refunds, but then we see a bunch of students who actually don't complete the first project. Interestingly, about half of those students, so about 10% of the whole cohort, watches all the videos, they just don't submit any projects. And so one of the things we're thinking about now is how to best serve students who are interested in the content but maybe don't necessarily want to do the projects, don't want to earn the Nanodegree credential. We're thinking a lot about how do we serve those students. Who never do a single project. About another 20% do the very first finding lane lines project but don't do the second project, which is the traffic sign classifier. So that's about 40% of the class total that we lose before the second project. And then about 50 to 60% of the class, of the cohort graduates. So basically, if you finish the traffic sign classifier in term 1, you are very likely to complete all of term 1. That said, I don't know the stats on term 2. I need to go look those up so I can, not look those up, but remind myself what they are so I can tell those to you. For this initial cohort in 3, we're going to have, I think, on the order of about 400 or 500 people, so almost the size of the initial October cohort. A number of students have gone through, started in later cohorts and went through really fast and caught up. And then there was a little bit of a larger gap than we anticipated, just because it took us a little longer than we thought to get everything teed up to launch term 3. And so with that gap too, some students have moved up into the earlier cohort, which we're excited about. We're really excited that that students are really enthusiastic about the material and want to be part of the first wave through. Every time we get new students who are kind of in that initial first cohort, I think it's always a little bit of a wake-up call to them, that maybe not a wake-up call, but an experience that sometimes the first pass through the content requires a little revision on our part, and we are really trying to be better about that, but it's almost inevitable. So we appreciate you if this is your first time being in the very first cohort through some of our instructional content. We really do appreciate the feedback, even when it's harsh, so that it helps us make things better for future students. Let's see. Ezra says, Udacity Unicorn, don't worry about us, will be public soon. I have no knowledge or comment about that. I guess it's not a question. Crezo says, what do you think about the current number of viewers of the stream? 5% of term 3. 100 people watching now is what I see. I think that's about par for the course for our live streams. The live streams are at a certain time of day, and we have students all around the world. And in the US, it's at the end of the workday, but not quite past the end of the workday, so people are working, and a lot of people come and watch the streams later. It actually seems maybe a little high. Oh, we just went from 99 to 100 viewers. Yay, us. Let's see. Tucker asks, is this the first term 3 cohort? I'm starting term 1 on 7/13, which is next week. And the answer is yes. Because of various delays, we've had kind of racing to get content out over the course of the last year. What started as the original October and then November cohorts for the very first term of the self-driving car Nanodegree have kind of been not quite compressed together, but drawn a lot closer than the 3 weeks I think they were originally offset, or maybe 1 month. And so now those 2 terms are starting basically a week apart. We debated whether to just combine them all together or not, but they're starting as separate terms so that students, if they want to, can do what we originally intended, which is go through with their original cohort. Let's see. Crezo asks, anyone having experience with automotive grade Linux? We'll be running standard Linux on Carla on the Udacity self-driving car, not an embedded Linux like Yocto or something like that. But we are running ROS and AutoWare, which are 2 really important open source automotive libraries. And so I think that'll be really fun to work with, and also really good to talk with employers about, that you've worked on actual automotive middleware, publish, subscribe systems. This is what almost everybody who kind of learns about autonomous vehicles kind of works on to start out with, and often companies, when they're building these things in production, have kind of their own secret sauce middleware. So so you kind of have to learn whatever your particular company is using when you join that company. Ezra says, I survived the first 2 terms due to walkthroughs. Are there going to be walkthroughs of projects in time for people in this inaugural cohort? And the answer is yes. We always do the walkthroughs. We try to provide enough guidance in the lessons and in the modules that the walkthroughs are not strictly necessary. We know sometimes we fall short of that, and we try and fix it. But we know the walkthroughs are really valuable to students. We try not to give away the entire answer in the walkthrough, but kind of get you started on the right track. And we'll have walkthroughs in term 3 as well. Let's see. I think I answered Ezra's question about the projects. The project release dates, the path planning project is actually ready now, even though it's labeled coming soon. We labeled it coming soon because the trajectory generation lesson won't be ready until next week. And then the elective modules, the concentrations, will be released in late July, so late this month. Tigerhead asks, will there be any hiring event after term 3? I'm not sure there will be an event per se, like a job fair at Udacity headquarters in Mountain View, California necessarily, because we have a global student base. That not wouldn't necessarily be helpful to everybody. We could do an online event. I might actually mention that. That's kind of an interesting idea to our. I can mention that to our careers team. I think in general, what we're trying to figure out is how do we do this in a way that's really scalable. So that's part of the drive behind the Hiring Partners Jobs Board that I showed you. We're also looking at a number of other initiatives with specific hiring partners to help them fill large chunks of positions that they have. We'll be announcing some of these other initiatives over the next few months. But we have thousands of students, and a lot of them are really excited to fill the thousands of roles that are open in the autonomous vehicle industry. And so we're trying to figure out how to really do this at scale. An online event could be kind of an interesting way of making that happen. I'll kind of brainstorm a little bit. Let's see. Mahmoud Salah asks, did you will add any new lessons for Project 1? I'm not quite sure if he means Project 1 for term, if you mean Project 1 for term 3, or like the original Finding Lane Lines project at the very beginning of the program. But for term 3, I think I mentioned we have 3 lessons. So search, prediction, and behavior are released now, and we'll be releasing trajectory generation next week, and that will lead all the way up to the first project in term 3. Ezra asks, can I do advanced deep learning without AWS? The answer to that is you can do it without AWS. It would be really difficult and slow to do without a GPU. So I think you mentioned later in the question you don't have a GPU. We'll be providing AWS credits to students who enroll in the advanced deep learning elective. Sorry, I should have mentioned that earlier, another $50 in AWS credits. And some sort of GPU-enabled solution is almost a requirement for advanced deep learning because the compute power of working on training semantic segmentation networks is so large, it's really hard to do without a GPU. As to the question, can you do both electives? Definitely. We're working on the exact business model for what doing an extra elective would cost or how we would make that work. Can you try when quit and switch? I don't think we have that set up. I mean, I don't know. I guess we'll kind of see as we go through this if you really start screaming about how terrible one elective is. I suppose maybe we can switch you into another one. We don't want students to be unhappy. But in general, we're not setting up a model where you can kind of try one and then switch. We're trying to give you the information that you need ahead of time and allowing you to choose whichever one you want to pursue. Let's see, there were a bunch of questions about just the AV of YouTube. Apologize for the difficulties there. Let's see, Rob Alley asks, is this term 100% C++? Pretty much, like the very first full lesson, the search lesson, comes out of AI for Robotics, Sebastian's free course that's available on udacity.com. I think I mentioned that provides some foundation for search theory, and that's actually in Python. But the projects are in C++, and most of the quizzes and such in C++ as well. Actually, Bruno makes a good point that I just glided right over when I was saying this term is in C++. Advanced deep learning is not in C++. So path planning is in C++. Advanced deep learning is in Python with TensorFlow. I apologize. And then systems integration is primarily going to be in C++, although there are some Python APIs to AutoWare that you might choose to use. Let's see, Kareem asks, are there plans to add additional specializations later? Yes, we definitely want to add more specializations. We have pipeline issues with getting multiple courses ready to go at the same time. It stretched us a little bit to the limit just to get advanced deep learning and functional safety ready to go at the same time as we were building all the other modules for term 3. But I think as we kind of wrap up a lot of the new content for the self-driving car Nanodegree program, we'll have a lot more resources to both improve content that we've already launched and to build new specializations. We're excited to build specializations in some of the other core areas of the course, like sensor fusion and path planning. Jeffrey asked if there are new electives. Will we get to participate? The answer is yes. We're working on a model for that, but we definitely want you to be able to take all the electives we build. It actually enables us to be able to build more electives. So that's something that we're figuring out. Let's see. Can we replicate Carla in the UK? Asks Crezo. Well, I certainly wouldn't tell you couldn't. But one of the things we have been clear about with the Nanodegree program is we're really designing the Nanodegree program to enable students to get jobs in the field, less so to actually like build your own self-driving car in your garage. It's really the ultimate goal is to help students get jobs in the field. So we don't actually even have instructions for building Carla. We bought some of the Carla hardware, not the software, but the hardware pre-built from a company called Autonomous Stuff, which basically takes Ford vehicles and makes them drive-by-wire, electronically drivable, not self-driving, but programmatically drivable. And so you could buy an Autonomous Stuff car and ship it to the UK probably, although it'd be set up to drive on the wrong side of the road. But we don't have specific instructions for doing that. Ezra asks, why is the car named Carla? I guess it's a little bit self-explanatory. It's a car and we named it Carla. That's really all there was to it. We thought we were being really clever. Maybe we weren't, but we thought it was a fun name. Innocent Jofac, I'm sorry if I'm missing that name, asks, how is the sim integration module going to work? I mean, since not everybody is in the Silicon Valley. That's a good question. I might have glided over that a little too quickly. The system integration module is going to be an experiment for Udacity in a lot of ways. We haven't done something like this before, and so we're kind of we have this vision for how it will work, but plans may change when reality actually sets in. The idea is we're going to put students in teams. We have a simulator and a development environment, so you can run AutoWare and ROS on your local machine or on an AWS instance. It does require Linux to run, so you might need to install a virtual machine. We'll have instructions for that. And you'll work with your team to build out different components of the software stack in the simulated environment. And our goal is to get the simulated environment to match up as closely as we can with the actual Udacity car and test track, so that there's a really high probability that if the code works in the simulator, that when we put it on the vehicle, it will work reasonably well too. And we'll give you several shots over the course of the final 6 weeks or so to put your code on the vehicle, run the code on the vehicle, give you video files and log files so you can figure out how to fix things that might not work. But it is kind of an experiment. Udacity's never done something like this before, and so we'll be kind of figuring this out as we go along with you. Chris Kale says he hopes Udacity has good insurance. We do have good insurance. We definitely had to get insurance for this, but there will always be a safety driver in the car. It's very safe. We're doing this on a closed test track. We definitely don't want to endanger anyone's safety as part of the Nanodegree program. We're very, very committed to safety before everything else as far as the car program, as far as the final project with the car goes. Louise asked, can we go to Udacity headquarters for the final project and run our code there in person? I think the answer to that is yes. We've talked about that a little bit. I think we need to figure out the logistics exactly, but we love to have students in general at Udacity headquarters in Mountain View, and particularly with students being so excited, we hope, for putting code on the car. We'd like to organize something so that as students come up to have their code run on their car, that they're able to come to the test track and watch it go. That's something we actually need to kind of figure out logistically, but I think we could make that happen and it would be a lot of fun. Ezra asks, what was your path? How did I become a self-driving car engineer? So I've told my story, I think in some random places, but I'm always happy to tell it again. I was a normal Silicon Valley web software engineer for about a decade, actually. And several years ago, I was working in recruiting software, of all things. And I decided I just needed to work in something else, something more exciting. And I got really, really excited about autonomous vehicles. but I didn't have any automotive software experience, any embedded software experience, any system software experience. So I started taking all these online classes at Udacity, at Coursera, at edX, as many online classes related to robotics and perception and machine learning as I could get my hands on. And I started doing independent projects and built my own little mini self-driving car remote control thing, and wrote a blog and applied to a bunch of different companies, and was fortunate to get a job on Ford Motor Company's autonomous vehicle team in Palo Alto, California. And Sebastian and Oliver Cameron, who now runs Voyage, saw that, and they said, well, David, why don't you come over to Udacity and do for other people what I had done for myself, but just less painfully and more structured. And to be honest, if you've completed even just the first 2 terms of the Nanodegree program, you know a lot more about autonomous vehicles than I did a few years ago when I got my first job in the field. So it's really impressive for students who've gotten this far, and we're really, really dedicated to helping students who've gotten this far get jobs in the field, because I think if you can make it through the first 2 terms and the 3rd term of the Nanodegree program, you've shown a lot of dedication to getting a job in this field, and you know how to do some really amazing things, and we want to help you put those amazing things to work. We're really, really proud of you. Let's see. Tucker asks, how do you, quote, work with a team of students to get our code on the car? We've never had group projects before. Great question. We never have had group projects before. This is another one of those new things with the self-driving car Nanodegree program and with this specific project. So what we imagine we're going to do is divide students into teams, probably on the order of about somewhere between about 10 and 20 students per team, and give you the list of things that need to be built, and have students self-organize and figure out what people want to work on, what topics based on interest level and availability, and use shared GitHub repositories to build and publish and manage the code. One thing that we're a little worried about is, we don't want it to turn into Lord of the Flies, where people in groups start fighting and get really upset with each other. So we're thinking about maybe lowering the stakes so there's not like a pass-fail aspect to this. It really is by this point kind of all about having fun working on the car. If you've done 8 months worth of projects, we don't have a lot of desire to fail you out of the program in the last project. So we just want this to be a really fun and amazing experience. If it feels like we just really need to provide a lot of project management resources in order to help teams of students work together to get code on the car, then we'll try and provide those, at least in a scalable way. But it is kind of an experiment for Udacity to have a group project, to have a project that entails getting code on an actual physical robot or vehicle. So there are a lot of things we're kind of figuring out as we go here. We have kind of theories of how they'll work, but we'll see how they work when we actually implement them. Let's see. I'm happy to keep going. I will just keep going and answer all the questions. I know some people probably have other things they need to do, so please don't feel compelled to stick around. But I'm happy to keep answering the questions, and thank you for asking. Tucker asks, do we wait in a queue for our code to run on Carla? I don't think it'll be so much a queue as we'll probably say that certain days are track days, and we'll just run whatever code you submit to us on a given track day and send you the results. So I don't think it'll be so much like you submit code and then sometime after we run everyone else's code we get to yours. It'll probably be more like there's specific days on which we run code. Let's see. Chris Callie asks, has there been any feedback from hiring partners on student progress so far? Yeah, we've had a bunch of students who've been hired into jobs at great companies, NVIDIA, Mercedes-Benz, BMW. Some of the feedback we've gotten has been really positive, that students have amazing dedication and excitement. Students have done really terrific things both in class and out of class. Some of the feedback for things that we can improve are C++ is a big one, particularly for students who haven't completed term 2 yet. A lot of employers in the autonomous vehicle world just won't hire someone who isn't proficient in C++. So we're continuing to build out our C++ course that where the lessons appear at the beginning of term 2, and it's actually now a course available on udacity.com as a standalone entity is our C++ course. And also just general interviewing practice. So it's a little bit strange, I guess, that some students will have great autonomous vehicle projects, and then they'll get into an interview and the question will be like, can you balance a binary search tree? And we haven't really prepared you for that because it's maybe not directly relevant to autonomous vehicles, but it is relevant to getting a job working on autonomous vehicles. And so we're working on trying to improve our preparation just for the technical interview process. We have some of that available already on udacity.com, our algorithms and data structures course, and just some general interview prep, but we're working on building that out a little more. Is there any documentation of the car when it is running our code that we can access later, videos, logs? Yeah, we'll send you videos and log files. We're in the process of kind of alpha testing the project right now with an early group of testers, and we're kind of building up the structure for what we need to send you back in order for this to be a successful project. And we should have a lot of that data as the month goes on. Cresso asks, what if we have startups and want access to venture capital? I don't have a great answer as far as how Udacity can help you on that one. We don't have like a venture capital funding arm. I guess if we see a lot of students who really want something like that, it might be something Udacity looks into, but it's not something we've considered too much so far, like an incubator or anything like that. But there are a lot of students both in the student Slack and the public Slack channel, and that might be a place to start, just asking fellow students, have you pitched any VCs or incubators, and what was the response, and was there anyone you might be willing to introduce me to? Medamin Ben Sadok asks, who can we email to plan a meetup or a small conference in SoCal? You can email me, david.silver@udacity.com, and I will connect you either with Elizabeth or the right person. We love to help students organize meetups with other students. I love to go meet students at different events. I was just in Denver last week meeting with students. It was a lot of fun. SoCal's not too far, and maybe we could arrange an opportunity for me to come down and meet you guys. Bruno asks, can you tell us a bit more about the Udacity Blitz plans for the self-driving car Nanodegree program? I can tell you what I know, but it's not that much. We'd like to do more with Blitz for the self-driving car program, but we haven't quite figured out the right way to do it. Udacity Blitz is almost Udacity's like consulting arm. It's not designed so much to be a consulting firm that makes money as it is to provide an opportunity for students to get work experience. And that works really, really well for web and mobile development, where there are lots and lots of people who have little web and mobile development projects that they'd like done, and they're happy to pay Udacity students to do them. And it gives Udacity students work experience and a foot in the door to a full-time job. That's a little bit more difficult with self-driving cars, where there aren't kind of little projects that companies can give us or startups can give us that we can do. It's much bigger than that, and so we're trying to figure out if there's a way to use Blitz to give Udacity students work experience in the autonomous vehicle industry, but we're still trying to figure it out. It's a little bit of a tough question. Let's see. Sampath asks, what are the statistics for term 3 and how many students are in the first batch? I think I mentioned, I think between 400 and 500 students are in the first batch because a number of students from the original October cohort have not continued on. Not so many, not that people have finished terms and then opted not to continue, a few of those, but a number of students have not always completed every term. But then we've had a lot of students from later terms catch up. Mahmoud asks, can you send us these statistics in email? Probably not. I don't know that everyone would necessarily want to get an email blast with all of the Udacity statistics. I try and put them up on my blog and on Twitter and in live chats and stuff when people ask, but we generally reserve sending mass emails for things students really, really need to know. But it's a good question. If you really want it in writing, you can send me an email, david.silver@udacity.com, and I can send you something back personally. Sampath asks, what is the graduation plan for the term? Will there be a physical nanodegree certificate? We provide an online certificate for everyone who completes all of their projects in any Nanodegree program, and that will be the case here as well. You can print it out yourself, but we don't actually print it out and mail them all around the world just because we have so many students all around the world. So yeah, so once you finish all the projects, you'll get your Nanodegree certificate. And it's a really impressive achievement. I was just seeing today a bunch of students put certificates from other nanodegrees up on LinkedIn, and we're really excited to see how proud students are of earning their certificates. Alex asked, what is the deadline for term 3 project submission? The deadline for the term is October 15th. So yeah, that's the deadline. Sampath asks, is the final project term-based? How will overseas students have access to the final hardware and car-based implementation, or team-based? The final project is team-based. I think I mentioned a minute ago about organizing students into teams of maybe 10 to 20, 15 to 20 people, and providing a development environment, and then specific track days where we'll organize or we'll run code from different teams on the vehicle. Let's see. Sampath asked about content for term 3 that is still not fully cooked, coming soon. Why is that? The not so secret of the Nanodegree program is we are like racing to get content out as fast as students can complete it. And some of it is frankly like challenging content to build. It's some of the most advanced content that Udacity produces, and maybe some of the most advanced computer science content anywhere. And so sometimes, you know, it takes us a little longer than we anticipated to get everything built up and ready to go. We are racing as hard as we can on it. We're about a week away from launching the final lesson of the path planning module, and a few weeks away from launching the elective modules. The elective modules have all been recorded. We're working on the animations now and the quizzes and getting everything all teed up in the classroom. So we're moving as fast as we can on it. Sometimes we need to move a little faster, and we apologize for falling behind. Luis asks, when is the live help option available? The live help option, I think should be available now, but because this is like the first time we're doing this in the self-driving car program, it may be that a few buttons need to be checked or clicked, or switches need to be flipped to get everything going for live help. So I'll check with our mentorship team right after this live stream and verify that everything's all good to go for live help. Tucker asked, what percentage of students are from the US? About 50%. We see about 50% of students from the US, a fairly large chunk of those. I'm not sure how many from the Bay Area, but definitely not like a majority, or at least not an overwhelming majority from the Bay Area, all over the country. We see about 20% of students from Europe, 7% of students specifically from Germany, which makes sense. Germany has a very large both population and automotive industry. About 7% of students from India, about 5% from China, 1% from Japan, and then the rest of students, you know, from all over the world: Australia, South America, Africa, the Middle East, everywhere. We're really proud of the geographic diversity of students and the locations in which students are participating in the Nanodegree. Sandro asks, how long will term 2 be available for those of us that haven't been able to finish all the projects? I still haven't finished the MPC project. Term 2 is following the same pattern that we ran for term 1, which is there's a 4-week extension, and then another paid 4-week extension after that. So if all you have left to do is the MPC project, I think there'll probably be enough time for you to complete that between the 2 extensions. Medamin Ben Sadak asks, what are the most important skills that hiring companies are searching? What is the standard? Just general idea if they are more focused on deep learning with C++, Python, advanced coding skills. Autonomous vehicle companies often search for candidates in certain positions that have certain skills. Some of the big overarching skills are proficiency with C++ is really important. For deep learning positions, Python, TensorFlow, are really important. Having worked with a lot of different deep learning models and architectures is important. So some of the architectures that or models that we've exposed you to in the core deep learning module, like ResNet, VGG, GoogleNet, AlexNet, having worked with those is important. Some of the cool stuff we'll be doing with encoder-decoder networks and semantic segmentation networks in the advanced deep learning module. That's really important. Sensor fusion and being able to build Kalman filters is really important. Kalman filters actually come into play in a lot of different places because they're basically a way of dealing with probabilistic data, and probabilistic data comes up all the time in autonomous vehicles. So extended Kalman filters, unscented Kalman filters, those are really, really important. And then for any given area, for localization stuff, particle filters are really important. Some of the stuff we'll hopefully be building with advanced elective modules, like for localization, maybe SLAM, simultaneous localization and mapping. It kind of varies a little bit by area, but the big overarching skills are coding ability with C++, some sort of experience with automotive middleware like ROS is really important, so you'll get that in term 3 as well. Carl asks, any thoughts on hardware-focused electives and projects in hiring for the field? This is what I've heard had the biggest needs. So one of the things that we've talked a little bit about is like helping students build their own little mini autonomous vehicles. I've written some stuff on my blog about how I did that, both before I got my job at Ford, and then actually I did a more advanced version of it at Ford. And it was a lot of fun, and I just felt like I learned so much building an actual self-driving car, even if it was a mini 1/10 scale remote control self-driving car. There's a lot of resources online for that. We might try and pull some of those into the classroom to kind of point you in a direction. It's a little hard for us to manage that as a required project, just shipping all the hardware out to people and dealing with hardware issues as they come up. Software is easier to work with students all around the world. But that's kind of an interesting idea for a hardware project. We're also thinking for some of the upcoming advanced electives of working more with real sensor data, so real LiDAR data, real radar data. I think that'd be a lot of fun. Then Stusme asks, what happens when I can't complete term 2 on time? Can I take more time? Yeah, I think I mentioned to a different student that term 2 is on the kind of the same path as term 1. There's an automatic 4-week extension and then a paid extension after that. Let's see. Rob asks, if you didn't use the AWS credits from term 1, do you still have access to it? You should. I believe the AWS credits just go in your account to use whenever you want. Mahmoud says, can you take the other elective after graduation? Yes, you should be able. We're working out a plan for students to be able to purchase or otherwise take as many of the electives as they want beyond the one that's required for the Nanodegree program. Sampath asks, will students have access to improvements in the course content at a later date after graduation? Yes. So as long as you complete each term, you get access to that term indefinitely. For forever is, I guess, a long time, but for the foreseeable future, you get access to that term. So as we fix things, as we add things, you'll get access to all of that as long as you complete the term or graduate the whole program. Sampath asks, is there a strong pull for candidate expected from industry of exposure for functional safety? I think functional safety is one of these really important things that that companies are really impressed when they see new candidates who know something about that or who are able to do functional safety analyses, because it's a skill that you generally really only build up through years in the automotive industry. And it's often something that a lot of people on teams in the automotive industry don't know so much about. And so having someone on the team who is able to handle functional safety is a really big plus. And that was a big part of what appealed to me in building out a functional safety module. Is I felt like it would help make students employable in kind of a really interesting and special way that other people, not coming out of the Nanodegree program might not have those skills. Let's see. Jeffrey asks, how large will teams be for the capstone project? I think we're thinking between 10 and 20 people. Let's see. Ramiz asked, when will the C++ course be available? I believe it's available on the Udacity website now, although we went back and forth for a while about launching it as a free course. I think we finally did launch it as a free course, but I will double check that it's just available on udacity.com for anybody to take. Subir asks, is there a possibility of a LiDAR elective along the lines of the Diddy Challenge? There is a possibility of a LiDAR elective along the lines of the Diddy Challenge. That's something that I think if we did an advanced sensor fusion module, it might look a lot like the Diddy Challenge, just maybe a little bit better organized. Let's see. I will be in the East, Sampath asks, I will be in the East Coast 2 months at our company and will experience autonomous prototypes. Do you entertain students visiting your campus to experience Carla? How to plan? Yes, we love to have students visit Udacity. I will say we're on the West Coast, not the East Coast. But if you can get to Mountain View, California, we always love to have students at the office. It's always a real delight for us. So just send me an email, david.silver@udacity.com. Let me know when you're going to be around. Rob asks, can I have access to Udacity Blitz projects in other areas if I've only taken self-driving car? I actually don't know the answer to that. I will check with the Blitz team. I would think so, but I don't know for sure. I will check with them. And actually, how will I get you back the answer? I guess the answer, as always, is send me an email, david.silver@udacity.com, and I'll check with the Blitz team and get you an answer. Sampath asks, is there any demand for mid-level folks with traditional automotive background with this Nanodegree on top? My jobs are entry level with 2 to 5 years of core computer science background. Yeah, I mean, I think someone with automotive experience and a computer science background in the Nanodegree is kind of like the perfect candidate for autonomous vehicle jobs. Not to say that, you know, if you don't check one or a few of those boxes that you can't work in the field. I got a job on autonomous vehicles without having taken the Nanodegree because there was no Nanodegree back when I got my job with Ford. But I think, you know, having a computer science background, having worked in the automotive industry, I mean, that's terrific experience. So I would think you would be a great candidate. Jeffrey asked, Diddy Challenge was great. Oh, that's really nice to hear. Sometimes the Diddy Challenge felt less than great, but I'm glad to know that for students, or at least for you, it was great. We did our best with the Diddy Challenge, but with the Voyage folks spinning out, sometimes some things got lost, and we worked really hard to try and make things smoother. So thank you so much for your appreciation for that. Will we run more challenges? I think it's likely we will run more challenges. Some of them will involve real data, some of them will involve simulator work, but I think challenges are a big part of the future of Udacity. We've hired a person whose whole job is just to run challenges across all of Udacity, so I foresee a lot more of that coming. Stusmi asks, did you mean only one extension of 4 weeks? I need at least 12 weeks. So typically we have, or the way the extensions work is we have one free 4-week extension on top of the original 14 weeks of the term. So that takes the whole time to 16 weeks. And then we have a paid 4-week extension that takes the time to the term, the time that you're able to submit projects to 20 weeks. Let's see, Mo asks, how much of deep learning will be taught in the terms and in which term mainly? Term 1 has our core deep learning module where you learn about deep neural networks, convolutional neural networks, behavioral cloning, and then advanced deep learning is an elective in term 3 where you learn about semantic segmentation and fully convolutional networks and inference optimizations. J. William Dunn asks, is there any chance of a team seriously crashing Carla or their safety protocols to prevent this? Yeah, so there, I mean, there's a chance of anything happening, I guess. You know, there's a chance the moon is made of green cheese. But it seems extremely unlikely that Carla would crash, given that we will be running the code in the simulator before we put it on the vehicle. And then we'll have a trained safety driver in the vehicle at all times. And so, and we'll have a blocked off test track. So, you know, we take safety very seriously, and we definitely don't want to have any safety incidents. But I guess there's always a chance of anything happening. Let's see. Luis asked about live help. I will double check with the mentorship team. Live help was supposed to be available when we launched, but maybe a button didn't get clicked. Little Grass says, I had tried a few applications, but I got turned down as they know that the only C++ experience is from the Udacity project. Do you have any advice on that? I guess one thing I would want to just start with is, did they evaluate your C++ ability, or did they just simply say, you know, you haven't worked on C++ anywhere else? If they didn't evaluate your ability, I would be really skeptical of whether they accurately, you know, assessed your ability to work in C++. If they evaluated your C++ ability and you know, the interview didn't go well, then I would, you know, encourage you to complete the Udacity C++ course if you haven't completed it, and to work through some of the books like Cracking the Coding Interview in C++ to make sure you're really super comfortable working in C++. And to apply to hiring partners through the Udacity Hiring Partner Jobs Board, because we can kind of work with you and make sure that that companies we put you in front of value the Nanodegree and are excited to interview you. Sampath says, kudos to the team at Udacity. We thank you very much. We really appreciate that. And kudos to you for making it this far. Stusny asks, instead of 20 total weeks, I'd like to have 24 weeks total. In general, we kind of feel like, well, I guess it's 22. It's 14 plus 4 plus 4. So I did the math wrong. It's 22 weeks with all the extensions. If you really need those last 2 weeks, for this one, I would say email self-driving car-support@udacity.com. If you can't get the right answer from them, you can email me at david.silver@udacity.com. We feel like 22 weeks, the original 14 weeks plus the free 4-week extension plus the paid 4-week extension should be like enough to finish all the projects, and you know, we don't kind of want things dragging out forever. But if you really, really need those extra 2 weeks, we can probably make something work. Sukbir says, David, you are awesome. My mom thinks so too. Thank you so much. I really appreciate that. Thank you very much. We work really hard, and we know, you know, sometimes we need to improve, but we really appreciate all of the students being so enthusiastic and supportive of Udacity. Let's see. Sampath asks, can graduating students contribute to the course in some manner, mentoring, grading, or improving course content? Yes, definitely. We always need project reviewers and project mentors. And if you ping at Stephen on the student Slack channel, Stephen can help you get set up as a mentor or a project reviewer. Also, we publish a lot of things we need help beta testing in the beta testing channel in the student Slack community. And so if you just join that channel, there'll be lots of opportunities to beta test advanced content and help us try and get it polished up before we send it out to the whole student community. Cool, you're welcome to everyone who says thank you. Andrew asks, how can Honeywell find more information about becoming a hiring partner? We would love to have Honeywell as a hiring partner. That would be so awesome. If you can just email me at david.silver@udacity.com. I'll get you connected with Kirsten Bailey, our director of employer relations, and we can get Honeywell signed up as a hiring partner. Masood says, thanks for putting term 3 together. I bet there was lots of work to be done, and still is. There is still lots of work to be done, but we are within sight of the finish line, and we're really excited about that. And we're really proud of what we've put together. We know there's a lot of work to be done and things to be improved, but we're really grateful to all of the students, all of you, for being so enthusiastic about the course and helping us so much in making this the best autonomous vehicle education course, I think, anywhere. So thank you so much for participating and helping us build this. I think that's about it. So I will call that a day here. Thanks everybody for everything. If you have any questions, email me or ping me on the student Slack. I should be more active there in the next few days now that we're getting settled with the term 3 content, and I'm a little bit less underwater. And see you in class. Bye-bye.